Hello everyone, I am Dr. Kairan Mubina MS, working as an Assistant Professor, Department of Physics at the Kodulappa College, Tirunelveli. Welcome you all to this session. In this video, we will explore what is spectroscopy, its principle, types and its application. And we will know why it's one of the most powerful tools for understanding the atomic and molecular world. Like every individual having their own fingerprint, every substance in the universe has its own light fingerprint too. This is the magic of spectroscopy. For example, in many movies and stories, you have probably seen crime solved with just a single drop of blood. Have you ever wondered how that is possible? The answer lies in spectroscopy working behind the scene. Let's see the spectroscopy in action. Imagine a drop of blood in the crime scene. From the image, you can see the interaction of light with the blood sample. Later on, the sample is analyzed to the spectrometer. Finally, we get the resulting unique absorption spectrum. It confirms the presence of hemoglobin. So, this is how the spectroscopy works behind this to solve a major crime scene. Let's deep dive into the topic. Now we will focus on 4 key objectives. Understand the concepts of spectroscopy, explain the principles of spectroscopy, introduce the types of spectroscopy and highlight the applications of spectroscopy in science and technology. First one is the concepts of spectroscopy. Spectroscopy is the most powerful tool for the study of atomic and molecular structure. It deals with interaction of electromagnetic radiation with matter in the form of atoms, molecules or ions. This is electromagnetic spectrum. This electromagnetic spectrum is categorized by their wavelength and frequencies. It ranges from high energy shorter wavelength gamma ray to lower energy longer wavelength radio waves. In spectroscopy, different regions of spectrum interact with matter in unique ways. For example, gamma rays and X-rays, it probe atomic nuclei and high energy transition. Ultraviolet and visible are used for electronic transitions in molecules. Infrared radiation interacts with molecular vibrations, helping identify chemical bonds. Microwaves is used in rotational spectroscopy, studying molecular rotations. Radio waves are used in techniques like NMR, that is nuclear magnetic resonance, which probes atomic environments. So, spectroscopy relies on these interactions to reveal critical information about the structure and composition of matter. Next, principle of spectroscopy. The basic principle of spectroscopy involves 3 key steps. First, the light source emits radiation. Second, the sample absorbs or scatters specific wavelength. Finally, a detector measures the transmitted or emitted light. This is the matter. It interacts with the electromagnetic radiation. Absorption happens. Emission, some of the light scattered, some of the light reflected. So, when electromagnetic radiation interacts with matter, several phenomena happened, including absorption, emission, scattering and reflection. These processes form a foundation of various spectroscopic techniques. It gets the 3 types of spectra: continuous spectra, absorption spectra and emission spectra. Continuous spectra obtained when white light passed through a prism. Absorption spectra, when a radiation hits the molecule in the ground state, then the molecule absorbs energy only if it matches the energy band gap. This causes the molecule transition upward. So the molecules is transit from ground state to excited state. It's create an absorption line in the spectrum. Likewise, emission spectra, a molecule in the excited state, that is higher energy state, is unstable. So it undergoes a downward transition from excited state to ground state. The process is known as emission. So this is the continuous absorption and emission spectra. So the absorption spectra, this gap, the dark branch is denotes that some of the light observed by the molecules. This light denotes that some of the light is emitted by the molecules. Types of spectroscopy. Spectroscopy can be classified into various types based on the interaction of light with matter. Each type is tailored for specific analysis and application. First one is the atomic spectroscopy. Atomic spectroscopy is interaction between electromagnetic radiation and atoms. Molecular spectroscopy is interaction between electromagnetic radiation and molecules. It studies the electronic transition between discrete energy levels in atoms. It explores molecular energy levels including electronic, vibrational and rotational transitions. The spectral lines result from electronic transition between energy levels in isolated atoms. It provides information about structure, bonding and dynamics of molecules. The atomic spectra shows sharp and well-defined lines. The molecular spectra gives broader bands. Then the atomic spectroscopy is used to find out elemental analysis and purity testing. The molecular spectroscopy is used to study the molecular structure, bonding and functional group analysis. So these are all the atomic and molecular spectroscopy branches, that is AAS, AES, AFS, XRF is coming under atomic spectroscopy. Then IR, Raman, U visible, NMR, mass spectrometry, microwave spectroscopy is coming under molecular spectroscopy. In the upcoming classes, we will explore each type of spectroscopy in detail. Then applications of spectroscopy. Applications of spectroscopy. Spectroscopy find application in diverse fields. NMR, that is MRI, NMR spectroscopy is used for imaging internal organs, diagnosing conditions like tumors or injuries. U visible spectroscopy, it measures food additives, contaminants and nutrient content. Mass spectrometry, it ensures purity and composition of drugs. Absorption spectroscopy monitors pollutants in air and water such as CO2, carbon dioxide, NOx, nitrates or heavy metals. Spectroscopic fingerprinting, that is IR and U visible spectroscopy, is used to identify substances like drugs, toxins and residues in crime investigations. Infrared spectroscopy detects water and organic compounds in space. So these are all the applications of spectroscopy in diverse fields. Thank you for your attention. Spectroscopy bridges the gap between light and matter, revealing insights into the world around us. Stay curious and explore the wonders of science. Thank you.